Good morning, everyone, and thank you for joining today's webinar. My name is Caroline Guo, and I'll be helping facilitate today's webinar. Today's webinar topic is Infrastructure Pipelines with Terraform Cloud, where we'll be walking through our recently released beta version of run triggers. This feature is a feature that makes way for Terraform Cloud to create full-fledged infrastructure pipelines. Our speaker today is John Schulman, Senior Product Manager for HashiCorp Terraform. John will provide additional forums for you to get in contact with him for any follow-up questions or feedback as well. And with that, let's get started, John.
All right, great. Thanks everybody for joining. Thanks, Carolyn. And again, a little bit about me. So my name is John Schulman. I'm a product manager here at HashiCorp, and I support Terraform, Terraform Cloud most specifically. I represent the team that built and delivered these the run triggers, working their way into infrastructure pipelines that we're going to discuss here today. So real quick, just an overview of what we're going to cover. Today's webinar, we're going to have an overview of what run triggers actually are, and we couldn't do that without a little bit of an introduction to Terraform Cloud Workspaces, just to make sure that everybody's on the same page. Then we'll talk about what run triggers actually are and what they do, and then we'll do a demo, the exciting fun stuff. We'll create some run triggers, we'll manage runs in linked workspaces, and ultimately I'll do a pretty cool deployment of Console and Vault, which are our service mesh tools and our secure storage tool on top of a GKE Kubernetes cluster using run triggers, kind of to show how they work. And then we'll have some time for Q&A at the end. So run triggers and Terraform Cloud. We have to start off just by setting a baseline level of assumption. So Terraform, open source, is a command line utility that's used to manage infrastructure as code. Many of you are probably familiar with how it works and what it does, but for those of you who aren't, basically it's a way for you to define infrastructure that you want to deploy and lifecycle and manage as code, which can then be ingressed and applied iteratively to itself so that we can always make sure that your running state matches the declared state that's in your code itself. It makes it very simple for folks to manage infrastructure as well as to author and create new infrastructure and all the complex interactions that happen there, between those different pieces. Terraform open source, it is just a command line utility, so you can download that, you run it locally. It stores its state, which is, the state of the running infrastructure locally on, your workstation or whatever, with options to put it into, remote state storage so that folks can share and use that state together. However, Terraform Cloud is sort of an evolution of Terraform open source, where we start introducing, this concept of automation and collaboration for everybody, so that teams can start to use Terraform together. They can collaborate and work on the same pieces of infrastructure, as a unit, because very few folks work in a vacuum. It also allows you to connect to VCS backend so that we can automatically detect changes to code that's in, a resource-controlled repository, as well as interaction, on PRs and merge requests and all those sort of things to really increase that collaboration story for folks working together in larger groups. There's a UI, it's a SaaS-based service, so you can just create a quick account, log in, and start using your existing Terraform code rather quickly and easily. It also has, shared state backend so that we have, a built-in state management engine to make sure that changes are made safely and securely and sequentially so that folks are not, stepping on each other and clobbering each other's states with their own kinds of changes. Everything is version controlled and it's easy to collaborate. One of the key ways that we enable all of this collaborative, work together, remote state backend kind of story is through this concept called Workspaces. Now, Workspaces, I'm going into this because they're pretty integral to the way that run triggers works. These workspaces are chunks of infrastructure that encapsulate, the users that might log into them, the state files that represent the infrastructure, the source-controlled repositories themselves can be linked to these workspaces. So everything is sort of managed as a unit. And so a workspace is typically a collection of infrastructure. It contains states and variables and users and, the code itself, the repositories. And typically most organizations will have many, many, many of these sort of collections. Since a workspace could represent a chunk of infrastructure, like say a web app and database tier for a traditional 3-tier kind of an application, or a Kubernetes cluster and the applications that run within that Kubernetes cluster, or say core networking and security that then every application team inherits and uses from there. There's lots of different ways that these workspaces can be broken down, based on what your organization needs to do. But until now, they were always pretty isolated from each other. Uh, we didn't have a great way to communicate across them. If you wanted to run multiple kinds of workspaces, do Terraform plan and apply against 3, 4, 10 workspaces, you needed to actually invoke each of these, either, manually through the UI or from the API or using command line verbs from a CI/CD tool, etc. So run triggers, we're introducing this today in order to give you a way to automatically link these workspaces together so that you can, you define a source workspace so that you have, kind of a parent-child relationship, so that the source workspace, when it receives an update, the child workspaces or, the descendants can automatically say, hey, I see something has changed, let's start a run. And because of the way workspaces break down and that they have their own individual concepts of ownership and user management and all that kind of great stuff, these workspace owners still retain control of their own infrastructure. So they have the final say over whether or not a change from a parent or an upstream source workspace impacts and affects their own workspace. And because of the way we've designed this, it's nonlinear. So these run triggers can be established in a way that creates these multi-leveled interactions where you have, a many-to-many kind of interaction where one source workspace can trigger 3, 5, 10 child workspaces, and those can each in turn 3, 5, 10 other workspaces. It doesn't need to be a linear progression. It can be very sort of interconnected. And that's with a view towards understanding that, infrastructure has different requirements for pipelining than your traditional application code does. App code tends to be much more linear because there will be gating functions, there will be test functions. You'll deploy a piece of code, test it, a piece of code, test it, kind of unit tests, and then maybe finally at the end you do an integration test, and it tends to be fairly linear. Whereas application code, stuff gets kind of switched out on a different schedule. Things tend to be more durable. They don't get changed or updated or replaced quite so often. And there's many different challenges that come along with infrastructure pipelining that lead it to be kind of visualized differently than we typically do with an application pipeline. So with all that being said, I think we'll go into a demo. So we'll just leave slide world for just a moment. And Terraform Cloud. This is what it looks like when you first log into Terraform Cloud. You see a list of workspaces. These workspaces are, again, those collections of infrastructure. I have 3 defined here today. One of them is representative of a cluster. That's a Kubernetes cluster. One of them is our console cluster, console, again, being that service mesh solution that HashiCorp makes. And then Vault being our secure management engine for managing secrets and things like that. What we're going to do is we're going to build a situation where this cluster gets expanded in order to support new applications, and then console is provisioned on top of it, and then Vault is provisioned into that console cluster, so that ultimately at the end of the day, we have a Vault implementation running with a GKE backend. So let's take a look quickly at some of these, what these repositories actually do. So for example, this cluster workspace, you can see I've got a list of all the runs here that I've run in the past. I additionally have all of the different states. I've done this demo a few times, so you can see there's a few different runs of it. But these are version controlled state management for the backend as it changes. And if we look at version control, we can see that this cluster workspace is linked to my Terraform Kubernetes repository in the cluster subfolder. So if we pop over into that repository, we can see, I've got a cluster, a console, and a Vault subfolder in that repo. And let's take a look at the cluster itself. So the code for this is actually fairly simple. We're initializing the Terraform remote backend, and it's pointing at my workspace, my organization, sorry, and my workspace, and instantiating the Google provider, which will give us the ability to create those GKE resources. Now, if we look into the GKE configuration, you'll see it. I won't go into great detail on all of it, but right here in specific, we've got this node count that's set to a variable of enable console and vault. And if that variable is set to true, it's going to set that node count to 3. If it's false or else, it's going to set it to a node size of 1. Now, if we look at the Kubernetes engine, I've already got this cluster provisioned and it's at a cluster size of 1. And the reason it's already provisioned is it takes a pretty decent amount of time to build this cluster from scratch. So now that it's already up and running, we're just going to scale it out. So first things first, let's take a look at our run triggers. And to do that, since we're going to define sources, I'm going to start with the console workspace, because console is going to be automatically queued once the cluster workspace completes its run, does its thing and scales out. So we'll go into console and we'll pick settings and run triggers. And in this case, you can see there's no workspaces selected, so we're just going to pick one and we'll pick the cluster workspace. Because what that means is anytime the cluster workspace successfully completes a run, the console workspace will trigger its own run in turn. And we'll do this one more time between Vault and console, because we want to install Vault once console is up and running. So we'll go to the Vault run triggers setting, and we'll set this to inherit from console, add workspace. So now that run trigger is created and this infrastructure pipeline, is now established. That's pretty basic. This one is fairly linear. The sky is the limit. You can see obviously we can connect multiple workspaces here, but this use case, we don't need to. We're in good shape with this as it is. So if we take a look back at the variables for this GKE cluster, we'll see here that enable console and vault variable that we referenced that's related directly to the count of this. So I'm going to change this to true, and I'm going to YOLO it straight into the master branch because it's Friday. We'll enable console and vault, commit directly to master. Cool. So now that that's done, if we flip back over into Terraform, we should see that the cluster workspace is now planning. It has automatically picked up the change in the repository, and that's in turn queued to run against this cluster workspace. So we take a look here at the plan. We'll see enable console and vault. My commit message is here. And here's the plan that we're going to run in the back end. And give this just a second to complete. There we are. Now, if we scroll up, we can see the big change here is that the node count is going from 1 to 3, and that's again because that variable was changed. We'll apply this and give it a chance to run. We'll scale that cluster. And while it's running, I just want to point out this new addition to the plan here, which is that we're indicating runs will automatically be queued in the following workspaces. And in this case, it is that console workspace. So if we were to click on that, it'll take us straight to the runs list for that, that console workspace. We don't have anything here now because that scale out is still happening. So if we look back here at the cluster and watch this run happen, this should just take a few seconds. And as the apply runs, we will see this Kubernetes cluster start scaling from 1 node to 3 nodes. And that should be happening now. Yeah, so the node pool is resizing currently. So we'll give that just a few seconds to run. Now, while that's happening, let's actually take a look at the console code. Now, in this case, we changed that enable console and vault variable in the cluster workspace. Now, how does that actually make its way down into console? How does it make its way into vault? And the way we're doing that is actually through the Terraform remote data source. So we're using a data source here, data.terraform remote state .cluster is my workspace. We're querying that workspace. We're looking at the outputs and checking for the value of enable console and vault. So if that enable console and vault is set to true and is being inherited from that that cluster workspace, we're going to set the count of this Helm chart resource to 1. It's otherwise set to 0, so it's 0 by default. But when that enable console and vault variable comes out, it will be set to true, and in turn, that will increase the count of Helm charts to 1, which will trigger a productive run in that workspace. So that's all happening, based on the data source. And really, data sources with this Terraform remote state, specifically data source, are particularly powerful with run triggers because they enable you to pass data between these workspaces so that you can really create meaningful links and transition information from one workspace to the other while you're also automatically triggering those workspaces. So this should only, there we go, all done. So the apply is finished. And in this case, you can see here, enable console and vault is set to true on the outputs, which based on that remote data source will pass that value into the console workspace. So we can see now the following runs have automatically been queued. This will take us straight to the run in the console workspace that indicates that automatic run. And this is probably, yeah, it's already ready to go. So we'll give it just a second because I'd like to come over and show here that this Kubernetes cluster, it should be scaled. It's still, yeah, there we are. Number of nodes is 3. And now if we look at the workloads, it may be 3 nodes, but there's no running workloads here. This is all just system workloads. It's a bare empty cluster. So we've got this console workspace. We've got an automatically queued run that came from the cluster workspace. And because we scaled the count from 0 to 1, oh, in this case, we won't see that because there was nothing here before. We're going to automatically provision that console Helm chart into GKE. So we'll confirm that. We'll say deploy console. There we are. And so that's going to run. This runs pretty quick. And we can see in turn, runs automatically queued in the following workspaces. Again, we're going back to that Vault workspace. So if we were to click in here in Vault, we'll see that, well, it's not there yet because the run hasn't completed, but this is where we'll see, a run for the Vault workspace to automatically provision a Vault Helm chart. Same sort of idea where that variable is increasing from 0 to 1 based on whether or not that enable console and Vault parent variable is set to true. So this usually runs very quickly, the console one. And we can probably see while it's running that there are some workloads starting up. So there we are. So the console server pod is available. The parent console pod is available. It's scaling up right now, which is why it's saying some of these pods have warnings. And that should complete in just a couple of seconds. There we are. So apply finished. And we've got our namespace for the console namespace and also the release name, which will be used actually as part of the name of the Vault cluster, which happens. And in turn, again, a run has been queued in the Vault workspace. So if we click into that, this should already be ready for us to go. But real quick, we'll connect into console. So we'll just forward the port that it's running on internally. And we'll open up that console. And here we are. It's a brand new, plain Jane, very vanilla kind of a console implementation. There's nothing running in it yet except for its own system services. But when we come back over here, we've got an automatically queued run coming from console in the Vault workspace, same sort of deal. And we'll say install Vault. Whoops. There we are. Okay. And this also runs pretty quick. So this is going to spin up, it's going to instantiate that Helm provider, it's going to connect to that console environment, and it's going to lay down Vault within it. Now this is usually super fast. So if we take a look here in the workloads, we should see we've already got that QA Vault cluster starting up. All the agents and things are starting to get ready for it. And in just, it's probably already ready. There we go. So there is our Vault service. It's got 3 pods available and ready. They're showing an error because they're not yet unsealed. We won't go into the details of how we do that today, but here's our Vault cluster. It's up and running and ready and available for us to use. So that sort of wraps up the demo portion of this, and I hope what we've highlighted here is the way that we can have workspaces automatically trigger runs off of each other so that you can kind of create a flow that's meaningful, application focused, and really relative to the business, the needs that you have to build that involves multiple workspaces, kind of how you can pass data in between them. So we also have enterprise provider. We have instructions for how to use things like those remote data sources. So you can set up, first of all, run triggers here within the TFE provider. The documentation is all available for how you can do and use that. And then we also have the TFE workspace data source, which is a great way to get things like IDs and data sources and all that kind of stuff. There's all this information is here within the Terraform Enterprise provider. So come back to our slides and we'll just sort of wrap up by saying, I want to point out we do have several tiers of Terraform Cloud. Terraform Cloud's free tier is free. It's free for up to 5 users, and everything that I showed you here today is available in that free tier. The VCS integration, the ability to use workspaces, secure variable storage on the back end, remote runs and applies, the entire API is available to you, the private module registry, which we didn't go into, but is also real useful for really breaking down configurations. That's all there. If you move up into the team tier, it's $20 per user per month. That's pretty transparent pricing. That adds stuff like team management, and you have the ability to have more users working on things. And then finally, when you get into the team and governance layer, that's where you get things like our Sentinel policy as code engine that allows you to define business-oriented guardrails as code, and also get cost estimation capabilities to see how much things will cost as you work on them. And so, we encourage you to get it started at the free tier. Take a look, play with things, figure out how you can use it, how you can adapt your workflows to the tool and vice versa. If you're looking to do that, it's just app.terraform.io and it'll forward you to this sign up link so you can get an account free of charge, no credit card needed or anything up front. We also have a great Learn platform. HashiCorp Learn is an interactive kind of CBT way to really work with our platforms and our tools. And understand how to use them. So we have a really super robust Terraform Learn track, especially around Terraform Cloud. There's a blog out there we released earlier in February with the beta version of infrastructure pipelines. So I encourage you to check that out. It's also got some contact info in there. And then we also have documentation available not only on the TFE provider like I showed you, but also on Run Triggers itself. So we'll be emailing everybody who signed up for the webinar a list of all of these links as well as the recording. And I encourage everybody to please take a look, try it out, and give us your feedback. If you look at that blog post, there is information on how to provide me and my team feedback quite directly. So with that, Carolyn, Q&A.
Yes. Thank you, John. Unfortunately, we will not be able to get through Q&A this time, but what I would like to say now is I'd like to close out the webinar and just thank everyone for joining in, listening, and thank you to John for going through a lovely presentation and a demo. So I hope everyone enjoyed today's webinar and have a better understanding of how you can use run triggers to create infrastructure pipelines. Again, if you don't have Terraform Cloud and are currently interested in trying it out, you can sign up for a free account and you can utilize Terraform Cloud for up to 5 users for free. And then if you're interested in Terraform Teams and Governance, you can upgrade in the billing section of your account or sign up for a 30-day free trial with no credit card charge. And then finally, as mentioned at the beginning of this webinar, it is recorded and we will be sending out the recording to everyone after post-processing. All right, thank you everyone and goodbye.
Bye.